Not going on. I want to practice these properties one more day. So what I'd like you guys to do is pause me. Try these. The only one you're going to have a tough time with and you should jump over is number 9, which I starred. That one kind of has a new rule, so you could skip over that one. But otherwise, take a few minutes, try these, and let's see how you do. So you should be pausing me now and doing these. All right, at this point, I hope you pause me and you try these on your own. Let's see how you did. So I'm going to take a look at these 3 things here and see what I can come up with. Now, notice all 3 of these are log 6, log base 6. So that means we can put them together. So we can do log base 6, keep that, 3 times 24 divided by 2. So that's what you guys should have come up with, right? And this is going to end up being, well, 2 can kill off the 24, make it a 12. So I'm getting log base 6, 36. Now, if you got that, it means you understand what's going on. This can actually keep going. What you need to say to yourself once you get down to the final step, if you're dealing with numbers, is can 36 be made from 6s? You say yes, you have to keep going. Because this is the same thing as saying 6 to what power is 36? Ah, that would be a 2. So this answer is the number 2. So that's something I want you to keep in mind. So at this point, I want you to pause this video again. Go through what you've done and see if that scenario applies anyplace else. So pause me. Go and look to see if you see any more situations where that might happen and fix it. All right, at this point, I think I'm back on again. And hopefully you checked. And let's move on to number 2. Now in 2, I have a double log. So I'm going to do good old PEMDAS. I'm going to do inside my parentheses first. So I'm looking there and it says log 10. Now, just like back up here, where 36 came from a 6, can 10 come from a 10? It sure can, right? 10 to what power makes 10? Number's 1. And we talked about this yesterday, where how when the base and the number are the same, it's always the number 1. So this question is really just asking, what's log 1? And that was also one of the special ones we talked about yesterday. Anytime you have a log and the number is 1, the answer is always going to be 0. There you go. Let's take a look at number 3 now. 3 is almost identical to number 2. Notice double log, so I'm starting in here. Hey, natural log of e. Again, the base is e. And this is going to be one, again, the most famous ones you're ever going to see. Natural log of e becomes a 1. And a log with a 1 is always 0. So I got 2 zeros in a row. Next one. All right. Take a look at this. Got my exponent rules here. So there's a couple ways of doing this. When I see it, I'm like, ooh, I know the natural log of e can become the number 1. So if I can get him alone, this question becomes easier. So he can actually fall down in front and get multiplied to the 2. This becomes 80 natural log of e. And then the beauty of this is that becomes the number 1. So the answer to this question is just 8. All right, next one. Division question. Now there are literally 2 different ways of doing this. I'm going to do it both ways so you can see it. The first way is to go, okay, this is division. The natural log of 1 minus the natural log of e to the 5th. And that becomes, oh, log of 1 is nothing. Minus 5 natural log of e. Oh, and what's the natural log of e? 1. So I'm getting negative 5. So that's one way of doing it. Or you could do it a different way. Another way of doing this was when you look at this, you say, okay, Miss Duffy, that's the same thing as saying the natural log of e e to the negative 5. Right? 1 over e to the 5th is the same thing as saying e to the negative 5. And that's the same thing as saying negative 5 natural log of e. And again, natural log of e is 1. So that's a little faster way of getting the negative 5. But both are 100% acceptable. All right, now let's talk about this guy. Log 1, log 10 to the 5th. Now, these do not become a subtraction question. Here is why. Let's look at this one. Notice in this question where I turn it into a subtraction question, how many logs do you see? Just 1. And that's when you see 1 log, that's when it can be turned into a subtraction question. This is actually 2 questions in 1. You want to know what is this and what is this. So this guy becomes, well, what's log of 1? 0 all over. This guy down here would be 5 log 10. And again, because this base is a 10, this is the number 1. So this is 0 over 5, which is 0. And there you go. Okay, number 7. All right, 7 actually is very similar to 9, which I didn't realize when I started these. So I'm going to start this one now. Right? These two are special. There's a special rule that's involved. And what I want to bring in is this base is obviously e, and this base here is obviously 10. Because logs and exponents are inverses of each other, they undo each other. And if you notice, this base is e being raised to an exponent of log base e. These guys actually kill each other off, leaving me with just the number 3 there. So this, essentially what's happening is these kill off, leaving me with that number. So we've got the 3. Minus, and then what's the natural log of e? 1. That answer is 2. So let's hop down now and look at number 9, because it's the same type thing. Because these are inverses of each other, they're going to actually eliminate each other. This answer is only 7. That's it. Piece of cake. All right, now let's go back and do 8. All right, that means, see how all of this is under the radical? That means log 10,000, right, would be to the 1/2 power, or the square root. So we actually have to do this first. So 10 to what power is 10,000? Now what you guys should know about tens, it's always the number of zeros it is, right? 10 to what power is 10? 1. There's 1 0. 10 to what power is 100? Hey, how many zeros do you see? 2. So 1, 2, there's 4 zeros, so this would be 4. So this would be 4 to the 1/2 power, or what's the square root of 4? That answer is 2. All right, how you guys doing? Let's look at number 10. There's a lot going on here. Now, notice, unlike number 1, see how all these bases were the same? So you could combine everything. Number 10, this is log base 4. This is log base 2. Different bases. We cannot combine these using multiplication. These are actually 2 separate math problems. So what I'm going to do is I'm going to call this x and this y. So what I want to do here is find out what each of these are and then add x and y together. So let's take a look at this guy. So I have 2 log base 4. I'm going to write this 2 to the 1/3 power equals x. All right, now this guy wants to go into the exponent. This becomes log base 4, 2 to the 2/3 equals x. And now we're going to figure this out. This is 4 to what power equals 2 to the 2/3, right? Well, this would be 2 squared. So I get 2x equals 2/3, right? I'm going to divide by 2, which is the same thing as multiplying by 1/2. So x equals 1/3. All right, so now I know x is 1/3. Now I'm going to do this again, but for this guy. So I know log 2, 32 to the 1/3 has to equal y. So that means 2 to the y has to equal 32 to the 1/3 power. Well, 32 is 2 to the 5th. So that means y would equal 5/3. So basically, I'm asking you to do 1/3 plus 5/3. That means this becomes 6/3. So the answer to this question for number 10 is 2. Tricky little sucker. And then finally, this guy. It's number 11. I'm going to bracket it off. Okay, now, first thing I look at are the bases. Oh, these two are the same. So I can put those together. Can't do him. So let's take a look at this. So I've got log base 2. Now, can 4 be made from 2? I'm hoping that's a quick one. Yeah, that's just the number 2. Right. Then this guy, 8. So let's do this. This would be log base 2. 8 to the 1/2 power, right? This would be 2 cubed to the 1/2 power. Right, now, got to clean this up. A couple ways of doing it. This would be the same as saying 3/2 log 2. And what is log 2? 1. So that would be minus 3/2. Now we just got to do this guy. All right, so let's take a look at this. I'm actually going to grab a piece of paper. So, log base 4, 2 to the 4th. Okay. 4 can fall in front, or, actually it'd be easier to think about it this way. That would be 16, right? 2 to the 4th is 16. Can 16 be made from 4? Sure can. It's the number 2. So this now becomes 2 plus 2 minus 3/2. Right, this would be 1.5. But I like to do it 8/2 minus 3/2. And that answer is 5/2. Tricky. These two are very difficult. These two are my old New Paltz final questions, so it gives you an idea of how tricky these could get. What I want you to do for me real quick with this new topic is do these two for me real quick. See what you would come up with. So pause me for a second and see. All right, so I'm hoping to pause me. So the problem is this 3 out in front first. So what you have to do is raise it to the 3 cubed. So bring him up to be his exponent. Then that exposes this. So these would cancel. And that's 27. All right? Now, if you didn't do that, pause it and try this one now with that change. Okay, this one should be e to the natural log of 4 to the 1/2 power, right? Again, there's an e here, so these cancel, which would make 4 to the 1/2, which means what's the square root of 4? And that is 2. All right, so today I don't have any other practice questions for you. What I want you to do is you have all those review packets for the final exam. I've done some stuff now where you can go through those packets, and there should be more questions you should be able to do. Tomorrow I'm going to put all this together and show you how to solve equations with all of this, and then we're going to be in good shape. After that, all we have to do are some finance questions, you know, compound interest. warm you up with that a little bit, and then we can turn our attention 100% to practicing for your final exam. So I hope you guys are doing well. Talk to you soon.